Welcome at ISC High Performance Hume's leading event for the HPC community. We'll talk to several global exhibitors and find out more about their latest developments and future trends. And now we'll take you along. You're a real expert concerning HPC, quantum. What is your daily business?
I'm building up a subsidiary in Munich that is devoted to semiconductor R&D and production. So we will actually have the first step in the whole value chain for Quandela located in Munich. When you think about Lucy, the quantum computer deployed within the Euro HPC core, already there we could see that strength playing out where the German company Atocube and Quandela went together for that bid and were able together to deploy that quantum computer into the HPC center in France.
Let's talk about photonic and the project Lucy. What can you tell us about?
What is interesting in Lucy, it's a photonic quantum computer of 12 qubit cells. So the goal for us is to provide a new category of quantum computer alongside to Ruby. Ruby is using neutral atoms, alongside to Kitty, which is coming next year, using 4 qubits. So Lucy is provided by Quandela, in which we already perform a lot of proof of concept with different industrial users. So I would say some examples. So we have up to 20 proof of concept since 4 years. But with Quandela particularly, we work with recently in the field of aeronautics, with Safran in the field of computational fluid dynamics. We work also with Thales in the field of defense for optimizing drones.
How important is it to collaborate with other market players?
Our partner Quandela sold a system to CA, so French Large Supercomputing Center, and we worked together to integrate it through our captive access solution, so that the integration was made in a record time of a few weeks, and now it's live at CA Supercomputing Center.
Really fast, only a few weeks?
Yeah, because we have really the missing part between the QPU, the experimental QPU, and the production environment of the HPC data center.
We've had quite a few announcements. One of the most exciting ones is our integration with Quandela. So Quandela builds a quantum processor out of photonic qubits, and they're using one of our products called NVQ-Link to tightly integrate that quantum processor with our GPUs for the purposes of something called quantum error correction.
Why is this integration so important?
What NVQ-Link does is it connects Quandela's quantum processors with microsecond level latency to GPUs, so they can take advantage of AI and accelerated computing.
Do you see trends?
So it's really important to come with a platform, to come with a certain number of APIs, development tools that are the foundation for this openness on one side, and then this customization on the other side. That's what we do with also our partners, usually integrators, like E4, for example, but also HPC centers that have their own teams to work on this integration.
And what's the new development?
New tools like Merlin that allow us to integrate quantum computing with AI developments. That's first platform. We also announced a partnership with NVIDIA to facilitate the tight connection between the graphical process unit and the QPUs. Here we want to address the community of AI developers that don't know about quantum computing. And that's basically by doing a full integration and making like fully transparent, an easy way to bring this new innovation to a broader list of end users and developers.
And we are currently hosting 2 quantum computers, one from Pascal, a French company providing cold atom photon computer, and Lucy from Quandela, which is a photon-based quantum computer.
And when we look forward, maybe 2 or 3 years, what are we talking about?
Sometimes people have the idea that quantum computers are very greedy on power. It's not true for all technologies. Some technologies are using superconducting qubits, which require very greedy cryostat. But some technology are using cold atom or photons, which do not require this kind of greedy devices. And there may be some quantum advantage coming from those technologies in terms of computing the same for less energy.
The ISC in 2 or 3 years, what will you present here?
Well, hopefully we will have a quantum computer that has built-in logical qubits and first error correction and a real push towards the universal fault-tolerant quantum computer at large scale. So that's clearly on our roadmap, and we're excited to come back and present to the community what we have.